Cool. All right, 2 new words, guys. 2 totally new words. Haven't heard these at any point, I believe. 2 words are discriminant and nature of the root. Here's what you need to know. You are going to use the discriminant to describe the roots, okay? Now, your first question is, well, what is the discriminant? This is the discriminant. B squared minus 4ac. Now, you should be thinking to yourself, well, hang on, Picardo, I've seen that before, right? That b squared minus 4ac is the thing that goes under the square root when you do the quadratic formula, right? Okay, so that phrase b squared minus 4ac is not new. You've used it. I'm now giving it a name, and the name is discriminant. Okay, so your question is, Picardo, what am I going to use the discriminant for? And what I'm going to tell you is you're going to use it to describe the roots and to have an understanding of what your parabola might look like without graphing it, right? And without doing really any algebra, okay? So here I have a parabola. Everybody agree? X squared plus 4x plus 13 equals 0. So here's what I want to do. I want to evaluate the discriminant. Because do you guys agree if I identify A, B, and C, put them in my calculator, and then type in b squared minus 4ac, it's going to spit a number out at me, right? That's what I want to do, okay? So in this case, a is 1, b is 4, c is 13. And so my goal is to first determine the value of the discriminant. And you guys make me proud because I'm seeing a whole bunch of people reaching for their calculator, right? Because that's exactly what you're going to do. You're going to store in your numbers, and you're going to evaluate your b squared minus 4ac. And we all remember that we have to make sure that we multiply a and c, right? So we're doing that, 4 times ac. And what do we get? Negative 36. Agreed? All right, now I want to take you back for a minute, guys, to before break. Okay? Had I asked you guys to use the quadratic formula, right? Jane, do you agree you would have done ABC? Do you agree you would have done b squared minus 4ac? You would have also done negative b and 2a, right? Okay, but I'm not asking you to do that. Okay, I'm not asking you to do that. So what would you do, Jane? You would take this negative 36 and you would wind up plugging it into this position, right? And what would maybe have you take a little bit of a step back? You have a radical, right? With what number underneath? A negative number. And we talked about that being a bad thing, right? It's a bad thing because that doesn't give me any roots, does it? It gives me what sort of solutions? Imaginary numbers, right? So I know because this number is negative and because this negative number would have went underneath the radical, that I have no real roots. I have no real roots. What I have is 2 imaginary roots. And actually, guys, that should have went like over here. So just put that over there. Guys, if you tried to polyroot that, you would have gotten one of these, right? What's that called? I gave that a name. What's that thing called when you just have squiggly brackets with nothing in it? Empty set. Yeah, very good. If you have an empty set, so again, anytime you guys see find the roots, I've taught you guys to do this, right? We're going right to polytools. We're going right to 1, 4, 13. And the fact that I get this tells me that there are no real roots. If there are no real roots, then there are probably going to be imaginary roots, right? And so we talked about the fact that we can go into that same area and change real to be complex. Now when I do 1, 4, 3, or 1, 4, 13, sorry. It gives me these, right? How many roots do I have? I have 2 of them, but what kind of roots are they? Imaginary roots, right? So if I ask you how many roots are there, you're going to say there are no roots, there are imaginary roots. Now, what is the difference between the two? Do imaginary roots create a parabola that crosses the x-axis? No, that's the whole point, right? Real roots we can visualize, we can see them crossing the x-axis. Imaginary roots, Blake, we can't, right? We can't see them. So the sketch of this, guys, is going to be as follows. There are a couple of things that we do know. Right off the bat, without doing any of the work that I just did, do you guys agree that this number represents the y-intercept? Can I plot that? Sure. So I'm going to plot the y-intercept at 13. Okay, talk to me about this parabola. Is it happy or sad? It's a happy parabola because the x squared term is positive. And I said there are no roots, right? So if I create a happy parabola, watch what I'm going to do. I'm going to create a happy parabola. How far am I going to go down? Above the x-axis before I do what? Turn around, right? So I know that my parabola has to look something like that. Cool, right? Is that a perfect sketch? No, but it's good enough in the fact that I know the y-intercept, I know the shape of the parabola, and I know it doesn't cross the x-axis. That good? Okay. So here's what I want you to know right now. If my discriminant is, what was special about this discriminant? It was negative. If my discriminant is negative, then I have no real roots. I have 2 imaginary roots. So far, so good? All right, cool. Second case. So what else could my discriminant be? Well, so far we said it could be a negative number. It could be a positive number. What else could it be? 0. It could also be 0, right? So those are my other cases, right? I need a positive number and a 0. All right, so in case 2, A is 1, B is -8, C is 16, B squared minus 4AC is? What'd you get? What'd you get? You got 0, right? Really quickly, guys, if I asked everybody in this room to answer the following problem and your whole second quarter depended on it, what is 2 plus 3? And I asked everybody in the room to write it down, right? And I collected that paper. How many answers would I have? Hopefully. No, I would have 30, wouldn't I? But how many answers would I have? I'd get 30 responses, but I would have 1 answer, right? So why do I share that with you? Because watch what's going to happen here. When I do polyroots, (1, -8, and 16, I get that. I get 4, 4. How many responses did I get? 2. I got two responses. I got a response of 4 and a response of 4. How many different answers did I get? 1. Let me show you why. If I asked you guys to factor this, right, by hand, I said, guys, let's factor this by hand. Do we have a number that multiplies to be 16 that adds to be -8? Yeah, you do. I need two numbers that multiply to be 16. Oh, yeah. So I hear 4. -4. Would you guys agree that -4 and -4 multiplies to be 16? Would you agree that it adds to be -8? So if you guys solve this, what would you get? You get two positive numbers that are both equal to what? There's your 4. You get two solutions, right? But they would be the same answer, wouldn't they? Yeah. So do you guys see what I mean by when I asked you guys what's 2 plus 3, I would get 30 responses, but all the responses would be the same. Here, I asked the calculator to find the roots of this. It gives me 2 responses, but both of those responses are the same. So if I asked you guys, how many roots are there? You're going to say there's only 1 root, even though I got a double response. Yep. Great. That's exactly why I'm showing it to you, because what you're going to do is this. Your roots are 4, 4, right? Yeah, that's your actual roots, right? 4 and 4. What that's called, guys, is a double root. And there's actually something really special about a double root. I want you to write this down. Anytime you have a double root, it's called a bounce root. And I'm going to show you what happens with a bounce root. Okay? Just remember, a double root is a bounce root. A double root is a bounce root. Okay, let's write down the number of roots and the nature of the roots. So you guys said that I have how many roots? 1 root. I have 1 root. Talk to me about that root. Well, is it a real number or an imaginary number? Okay, so let's actually write down. It's a real root. 1 real root. All right, so let's sketch it. Give me a piece of information that I know undoubtedly, sure thing, no question about it. Positive parabola, happy. Y-intercept is 16. And I have a root of 4. Exactly. And guys, hey, watch, ready? Look up here, look up here. We know it's a happy parabola, right? What did I say about a double root? I can call it a bounce root, because watch what it's going to do. It's going to go down to that root. It's going to hit it and bounce off of it. Anytime you have a double root, it's going to come, hit it, and bounce back up. That's a bounce root. It absolutely could. Yep, it could happen to any kind of parabola. Cool? All right, so that's our second scenario. So far, what do we have, guys? We have a negative discriminant gives me no roots. We have a discriminant equal to 0 gives me 1 real root. I can visualize it. I can see it, right? That parabola crosses the x-axis, no doubt about it. Good so far? What are my other scenarios? My discriminant is not 0. It is not negative. It is positive. Well, Picardo, why do you have 2 different scenarios set up? You're going to see right now. Okay? You're going to see right now. All right, so my A is 2. And my B is -7. And my C is -4. Go ahead and get me a discriminant. Actually, this is what I want you guys to do. I'm going to give you guys 2 minutes. get me the discriminant, and then get me the roots for both of these. And you can use polyroots to do that, guys. Use polyroots to do that. Okay, do we got a b squared minus 4ac for example C here? What do we have for case number 3? Okay, you gave me the roots. Negative 1/2 and 4. What'd you get for this though, the discriminant? 81, guys? Does that sound good? Okay. Guys, where did this come from? How did I get these? You guys did what? You better have done polyroots, right? Negative 1/2 and 4. Is this what we got for the other one? These weird numbers, right? These decimals. Yeah, I want to write down the decimals. Yep. Yep, this is for the fourth case. Yep, we polyrooted both of those, right? So go ahead and write these decimals down. They're not real nice. 1.5359, 1.5359, 8.4641. And did you guys get a discriminant for case 4 yet? 48? All right. Guys, would it be fair to say, tell me if I'm speaking out of place, would it be fair to say that getting this and this and this and this is nothing more than an exercise in plugging things into the calculator correctly? Everybody okay with that? Okay. What do you notice about both of the discriminants? 81 and 48. They are both positive numbers. Everybody agree with that? Okay, so when I describe these, how many roots did I get in the first case? 2. How many roots did I get in the second case? Are they real numbers or imaginary numbers? Okay, so for both of these, I got 2 real roots. Right? What's the difference between these roots here and these roots here? Okay, and C, one of them's negative, one of them's positive. I agree with that. Okay, and D, there's some decimals. Let me ask you this. If I was to go back up here and look at these, do you think these are exactly the roots or do you think they rounded? In fact, how can I check it? I can highlight it and hit enter, right? And do you see how these decimals just keep going? What do we call answers that have decimals that just keep going like that? Say again? repeat. Okay, so I agree. Is there a pattern to the way that these are repeating? No. Is it the same number that keeps repeating over and over again? No. So if you have a weird decimal where nothing repeats and nothing happens over and over and over again like that, or doesn't look like one of these, what do you call that? Rational or irrational? Irrational. So in this case right here, I have two real roots that are irrational. And what, guys, why is that important? When you plot an irrational root, are you really plotting the exact spot? No, because it's a rounded answer, right? How about up here? Can you plot exactly where -1/2 is and where 4 is? Yes. So these are two rational roots. You guys want to know how you can decipher between the two? Ready? What's special about 81? It's a perfect square, right? 81 is a perfect square, guys, right? And hey, let's go back to the very, very beginning of what we talked about. What did I say we would do with the 81 if we did the actual quadratic formula? It would get plugged into this, right? What's the square root of 81? 9. So when I evaluate it, I'm going to get nice answers, aren't I? When I plug in the square root of 48, is 48 perfect? No, so I'm going to get weird decimals. Do we see why those happen now? Right? Okay. So the 81 gives me real rational roots because it's a perfect square. The 48, which is not a perfect square, still gives me two roots, but they are irrational roots. Cool? Okay. Guys, the sketch of both of these look exactly the same. I'm going to have two roots. I'm going to visualize them. I'm going to see them, right? So for this one, I have that. That's my y-intercept. I have a root at -1/2 and 4, and so it looks like one of these. Right? Two roots, here and here. What does the next one look like? Y-intercept of 13. Two roots at 1.5359 and 8.4641. What did I say? They're going to look very, very similar, aren't they? Right? They're going to look very, very similar, like that. So, T, on the next page, what I've done is I've summarized all four cases. Okay? What we have is we have all four cases put into this nice chart. Okay? So, this is the summary, and we're just going to add a couple of little notes to help us use this, okay? Guys, if the discriminant is less than 0, I get a negative number, right? And if I get a negative number, then that means I have imaginary roots, right? If I get a discriminant that equals 0, that means I have one root. And what did I call it? A double root or a bounce root. If I have a discriminant that is a perfect square, 100, 4, 16, 25, 121, 49. Those would all be examples, wouldn't they? Then I have two real irrational roots. Why do I use that word unequal? Because if they were equal, then I would be in case number 2. Yeah. So I'm using unequal just to say that they are not the same. And then I could have a positive non-perfect square, something like 3, 17, 130. Then I have two unequal, real, but irrational roots. Okay, here's what I'm going to have you guys do. All I want you to do, spend 5 minutes on this next page. All right, and the directions are as follows. Find the discriminant. All I want you to do. Find the discriminant for these 6 cases. So if I say find the discriminant, you're going to respond with what? A number. Good. A number. Absolutely. I'm going to rely on you guys to give me the right answers here, okay? What do you got for A? 81? And guys, if you get any of these wrong, what does that mean? That means you did one of two things incorrectly. What are they? You plugged the wrong numbers in for A, B, and C, or I don't know, I mean, B squared minus 4AC, you did something, you didn't type B squared minus 4AC in your calculator, right? I mean, that's the only things you could really do, okay? What do we get for the next one? For C? For D? 24? E? 148? 120? What is that one? 128. And the last one? 25. Okay. And if you got any of those wrong, guys, just check your A, B's, and C's and make sure that you have the right signs in front of them, because that's usually where the mistake's made, right? So what do we have? We have some that are positive, some that are negative, and some that are equal to 0, right? And this is where we're now going to what? We're going to describe the roots. So you're going to tell me three things. How many? Are they real and imaginary? Are they rational or irrational? Which two can I do really, really quickly? B and D. Why? Because they're negatives, right? And if I have negative numbers, I know I have no real roots. I have two imaginary roots. All right, so those two are easy to do, right? The negative ones are simple, okay? What's special about C? If I get 0, that means I have what kind of a root? A double, a bounce, right? So how many roots do I actually have? I have one real. Here's the other thing, guys. What's the square root of 0? 0. So when I plug 0 into the quadratic formula, I'm going to get nice answers, right? So are those answers going to be rational or irrational? Very good. I'm going to have one real and rational root. By the way, 0 is also a perfect square, right? So that kind of helps with that. How about our last three examples? They're all going to give me what? Two real roots. Why? Because they're all positive. They're all going to have two real roots. What word am I going to add to all three of these? Either the word rational or irrational, right? And what made the roots rational? If the discriminant was a perfect square. Is 81 perfect? So this is rational. Is 128 perfect? No, so this is irrational. And the last one is rational because 25 is a perfect square. All right, I'm only going to do example 51 with you guys. We're not going to do example 52. It's basically the same question. So we'll cross this one out. And what does the question ask? It says, which of the following when graphed would not cross the x-axis? So what does that tell me? If a parabola does not cross the x-axis, does it have any visual roots? If it doesn't have any visual roots, then the roots must have been imaginary roots. So this means I have imaginary roots or a discriminant that is negative, less than 0, right? So your first thought when you see this problem is, okay, I can handle this because I can find the discriminant for all four examples, right? but maybe we can make our job a little bit easier. You want to see how? Look at example 1. What do you notice about example 1? Is example 1 a happy or sad parabola? Happy. What's the y-intercept in example 1? Guys, if I have a y-intercept here, and it's a happy parabola, it has to what? It has to cross the x-axis, doesn't it? So would I bother testing choice 1? No. How about choice 2? What's special about choice 2? It's a sad parabola with a y-intercept of 6. What has to happen? It has to cross the x-axis. So what about examples 3 and 4? Well, example 3 and 4 have the following problem. Those are the y-intercepts for both of them, right? They're both happy, right? So Blake, here's the problem. Does it do this? Or does it do that, right? Are both of those likely? Yeah, they're both possible, right? Those are both possible scenarios. But I need to test both 3 and 4, right? Giuliani thinks it's 4. All right, we'll test choice 4. I think you're wrong. Yeah. It's 1. That's going to be oh, you're actually trying to factor it. Why? Why not just evaluate the discriminant to see if it's negative? Because if the discriminant's negative, that means it has no roots. See what I'm saying? What did we get for this one? 121? So that's no good. All right, so it's got to be choice 3. And in fact, if you evaluated this, you would get a negative discriminant, wouldn't you? Guys, what else could I have done? I mean, if this were a test question, would you do what I just did? You would have graphed it and looked at the darn thing, right? Yeah, of course. I mean, if this were a question on an exam, that would be the best course of action, wouldn't it? Right? What else would be a good course of action? Maybe I don't want to graph it. Maybe I just want to polyroot it to figure out which one gives me the empty set, right? 4, -4, and 5. Four, -4, and 5. This was choice 3. Gives, don't do this. And there's your empty set, right? So there's no roots. So guys, what I showed you there was an application of how you might use the discriminant to solve a problem, okay? The best course of action would be what I just did, okay? Tomorrow, what we're going to do is we're going to look at some weird cases of the discriminant where it's used, okay? And finish up one little tiny piece that's super, super easy, okay? That's super, super easy. You guys will do great with it. I'm going to give you the last 12 minutes here to get some work done.